Okay, so today we're talking about angles in circles. The first one we've already really talked about, so it's the vertex is where the angle meets. Okay, so when we're talking about the vertex location in these two cases, the vertex or where the angle meets together is in the center of the circle. So we actually already know this one. The angle is equal to the arc. So if the angle is 50, the arc is 50. And this one, the arc is 20, so the angle is 20. If I wanted to find this one below it, I would do 180 minus 20, and I would get 160. So this angle is 160, which also makes this arc here 160. Okay. So really the formula we begin with, the measure of the angle is just equal to the arc measure. Okay, that's only for angles that are in the center of the circle. Okay, so let's look at our first three examples. So this one is asking us to find x. So I need to find what this really should be, and what the value of 6x minus 8 should be. I do know that this arc is the same as this angle. So if I can find that angle, I just got to set it equal to the 6x minus 8. So these form a straight line, so they add up to 180. So 180 minus 140 ends up giving me 40. So this angle here is actually 40, which means 6x minus 8 is also equal to 40. Okay, so then I'm going to add 8 to the other side. I get 6x equals 48, and x equals 8 when I divide by 6. Okay, so there's our first problem done. Number 2, it asks for the measure of KL. So I'm looking for this arc length, KL. And remember, the angle is equal to the arc. So if I can find this angle, then I know it's the same as this arc. So again, this one, we have a straight line, so these two angles have to add up to 180. So 180 minus 21 ends up giving us 159. So this arc here is 159, which is arc KL, which is what we're trying to find. Okay. Number 3, similar. So I do know that this angle is equal to that, and this angle is equal to this arc. So these two together are forming a straight line, so they're actually going to add up to 180. So 17x minus 41 plus 5x plus 23 is equal to 180. Okay, so we simplify that by combining the terms. 22x minus 18. We're going to add 18 to the other side, so we get 22x equals 198. Divide each side by 22, so x is equal to 9. The problem is the question asks for kj. So I'm actually going to need to take my x and plug it back in to find this arc length, kj. So 5 times 9 plus 23 ends up giving me 68. So this arc kj is 63. And that is very similar to the stuff that we did yesterday. So now really we're going to start some new ones. So whenever I have an angle like this, so anytime the vertex is on the circle, okay? So what happens, we have this angle here, the vertex of this angle is x, so that's on the circle. So what happens is the arc, or the angle is half the arc. So I would take 62 and divide it by 2 to find out that this angle in here is 31. The kind of spin-off of that is that if they have the same arc, then the angles have to be congruent. Okay, so same arc, same angles, so these angles would be equal. I don't actually know what they're equal to yet, but it is a spin-off that these are equal to each other. Okay, and this one of the spin-offs is if you have this angle here, and the vertex is on the circle, and the inscribed arc, or the arc that they're really talking about, is up here. That arc is exactly half of the circle. So if I take 180 and I divide it by 2, this angle ends up being a right angle. Okay, because 180 divided by 2 is 90. So the overall formula for when you have something on the circle is that the angle is equal to half of the arc. And it's the arc that's on the inside of this angle. So it's not this arc over here, it's not AC, it's the one that's between the angle itself. Okay, so some examples with this. So first off, we check if this angle, vertex is on the circle, so the angle is going to be half of the arc. That's the formula I used. So half of the arc we're talking about is 116, because that's what's in the inside. So half of 116 gives me that x equals 58. All right. So number 2 here, we're trying to find angle RPS. So we're trying to find that angle. Vertex is P, it's on the circle. So it's actually going to be half. It'd be half of what this arc is. I don't know what that arc is yet. I do know that a whole circle adds up to 360. So if I take 360 and subtract this 114 and subtract the 136, I will find out that that arc PS is 110. Okay. So this arc is 110, and then to find the actual angle itself, the angle is equal to half of the arc. So half of 110 means that angle RPS is equal to 55. Okay, so again, they look different, but the thing they have in common is that their angle is all on the vertex. Or sorry, their vertex is on the circle. Okay, so this one, you look, we have this angle here, and we also have this angle here. What those two have in common is that they have the same arc. Okay, I don't know what that arc is, but I don't really need to know what that arc is to solve this problem. What I do know is that each of these angles are going to be half of that. So since it's the same arc, it means these angles are congruent. So I'm just going to take 8x minus 4 and set it equal to 6x plus 2, and then solve. So I'm going to subtract 6x, 2x minus 4 is 2, add the 4 over, you get 2x equals 6. So x is going to equal 3. And that's all the problem is asking for, so we're done. Alright? So on to the next page. So we have 2 more formulas. This one is the outside of the circle. So one thing you notice, all of these, they're similar, but they are slightly different. The nice thing is it's all the same formula. So what happens is inside this angle, we have a big arc. So inside this angle, we also have a big arc. And inside this angle, we have a big arc. And then we also have a small arc. We have this one, which is small. We have this one, which is small. And this one is small. So the formula for this is that the angle is equal to half of the big arc minus the small arc. So we subtract them and take half. Okay. So looking at our first problem, first important thing is that our vertex is on the outside of the circle. So if I look, 120 is my big arc, and 50 is my small arc. So I'm going to do that the angle is equal to half of big minus small. So when I plug this in, I'd have 1/2 times whatever 120 minus 50 is. So when I do 120 minus 50, I get 70. Half of 70 is 35. So that angle x ends up being 35. Okay, number 2 is a little bit more complicated. So one thing is we have big arc around the outside, and we have this small arc, which is our x here. Okay, so this is our small, that's our big. Problem is we don't have anything for the big arc. But if you look together, the big and small form a whole circle. So if I knew what that one, the small one, was, I could find the big one by taking 360 and subtracting it. So I'm going to make my big arc 360 minus x. And now I'm going to set up my equation. So in this case, the angle, so our equation is angle is equal to half of big minus small. My angle I have is 50. my big arc is 360 minus x, and then I'm going to subtract the small arc, so subtract x. So I know this equation looks kind of complicated. It's not terrible. So I'm going to actually multiply by 2 to get rid of this fraction. And at the same time, I'm going to combine my like terms. So I end up getting 100 equals 360 minus 2x. So then I'm going to subtract 360. I get negative 260 equals negative 2x. And I divide by negative 2 to find out that x equals 130. So the small arc in this case is 130. Okay. Moving on to number 3. So number 3 is another one. It's on the outside. I have the angle. I have my big arc, but I don't know what my small arc is. So they're actually going to make me solve the small arc. So my formula is angle is equal to 1/2 big minus small. So when I plug in, my angle is 80. My big arc is 185. My small arc I don't know, so I'm going to make that x. So to solve this, you multiply both sides by 2 to get that fraction to go away. So I get 160 equals 185 minus x. And then I'm going to subtract 185 from both sides. I get negative 25 equals negative x. So my x is just going to be 25. So moving on to the fourth example in this case. So first off, vertex is on the outside, asking you to find ABD. So if I trace ABD, it's asking me to find what this angle measure is. Clearly on the outside. So I need my big arc and my small arc. Here's my big arc. And my small arc is 62. I have that one already. But I got to figure out what this red arc is or what my big arc is. Remember, a whole circle is 360 degrees. So I'm going to subtract 62 and subtract 88 to figure out what my big arc is in that case, and it ends up being 210. So big arc is 210. And now I plug into my formula. So angle is equal to 1/2 of big minus small. So I have 1/2 of 210 minus 62. So when I plug that into my equation, I end up getting 74. Okay, so the measure of ABD is 74. Okay. We have one more equation to do. I think this one is the toughest, so the next one is a little bit easier. So the next one is talking about when we have an intersection inside the circle. So this is inside the circle. It creates two angles. Right now we're going to talk about angle 2. You remember these are vertical angles, so they're the same. What you need for this one is you need this arc and this one. So basically we're finding the average of them. So we're going to take the angle is equal to 1/2 of the two arcs added together. So I would add my blue arcs together and divide by 2. So let's do some examples. So in number 1, they're asking me to find the measure of angle 3, so that means I need 76 and 88. So if the angle is equal to 1/2 the arcs added together, I end up with 1/2 76 plus 88. When I plug that into my calculator, I end up getting the measure of angle 3 is 82. So once you set up the equations, just plug it into your calculator. Number 2 is the same way, so angle 4 is what we're looking for. So we need this arc and this arc, which we have. So it's going to be 1/2 75 plus 45. And when I plug that into my calculator, I end up getting 30. So the measure of angle 4 is 30 degrees. Okay. Number 3 is a little bit more difficult. So they want us to find the measure of CDE. So right now we're looking for an arc. Okay, so this is one of the arcs that goes into our formula. 128 is actually the angle measure, and then 73 is the other arc. So I've got to plug into my formula. So angle is equal to 1/2 arc plus arc. So I have 1/2, or sorry, the angle measure is 128, so I should plug that in. One arc is 73. The other arc, I don't know, so I'm going to make it x. And then I'm going to solve this. So to get rid of the fraction, we multiply by 2 to get those to cancel. So 2 times 128 is 256. And then I have 73 plus x. To solve that, I'm going to subtract 73 from both sides. So I end up getting x equals 183, which means that this arc, CDE, is 183. And you can always check your answer by plugging 183 and 73 back into here and seeing if it equals 128. All right, so the rest of these are practice problems. They're all mixed. Okay, so I'm gonna stop my video here. There will be another video that goes over those. When you're done with those, you're going to work on a practice worksheet.